Prove that root 2 is an irrational number. What is an irrational number? It is non-terminating, non-repeating decimal expansion. Definitely root 2 is a irrational number. Similarly root 3, not root 4, root 5, root 6, pi, etc. are the examples for irrational number. Let us assume that root 2 is a rational number. On the contrary, let us assume that root 2 is a rational number. If you are going to prove root 3 is an irrational number, the same process you have to follow. Instead of root 2, you have to write root 3. That's all. So we can express root 2 in the form of p by q, where p and q both belongs to whole numbers and they are co-primes. Co-primes means they have only one as a factor. No, they cannot be written in the reduced form, and q not equal to 0. Here, if you are going to prove root 3 is an irrational number, then also you have to follow the same process. Then squaring on both sides. Root 2 square p by q the whole square. Here also you have to follow the same process. Here 2 is equal to p square by q square. Here also same. Then transpose 2 to this q square to this side. 2q square is equal to p square. It implies that p square has two factors, 2 and q square. So it means that 2 divides p square. It also means 2 divides what? P. Let it be equation number 1. Here also if you continue this one, here comes 3 divides p. Okay, let it be. Let us continue. Then let us think that p is equal to 2k, where k is an integer. Now we can say that the factors of p are 2 and k. Now let us square on both sides. P square is equal to 4k square. But we know that what? P square is equal to 2q square. Now let us replace 2q square is equal to 4k square. Here 2 ones are, 2 twos are. Q square is equal to 2k square. So q square has two factors, 2 and k square. If we are going to prove root 3 is an irrational number, then q square is equal to 3k square it comes. Okay, 2 divides q square, isn't it? It implies that 2 divides q square. It also implies that 2 also divides q. So let it be 2. Here you observed that 2 divides p. Here you observed that 2 divides q. So our assumption that root 2 is a rational number is wrong. Here we have taken it as p and q have the factors none other than 1. Here 2 is also a factor of p. So our assumption is wrong. So root 2 is an irrational number.